This is Rachel Bixel, Andrew Oburn, and Danica Christensen, and we'll be talking about Chapter 7, How to Design Our Organization and Architecture with Conway's Law in mind. In this presentation, we will talk about what Conway's Law is, the different organizational archetypes, consequences of using Conway's Law the wrong way, incorporating Conway's Law into structures and traits, and lastly, using Conway's Law the right way. In 1968, Dr. Melvin Conway performed an experiment where 8 people were to produce a COBOL and an OGOL compiler. 5 of them were assigned to the COBOL and 3 to the OGOL job. The outcome was that the COBOL compiler ran in 5 phases and the OGOL compiler ran in 3. Conway's Law is just this. An organization team will be congruent with the organization of the software. The more members you have, the less flexibility. Etsy is an example of this within a larger organization. Etsy used to use Sprouter, a stored procedure router that was supposed to help make life easier for developers and database teams by bringing together the PHP code from dev and SQL from DBAs. Sadly, it didn't help the situation. Instead, every time a new site functionality was to be made, DBAs had to write a new stored procedure. This meant that developers had to wait on the DBAs if they wanted to add a new functionality. Sprouter was also tightly coupled to the data stored procedure. Sprouter had to be updated every time a stored procedure was changed. At first, there was only 2 teams/phases, but with Sprouter, there were now 3 phases. This created things like long queues and longer lead times. Over a 2-year period, Etsy eliminated Sprouter. They did this by reducing the number of teams, which reduced the need for teams to coordinate changes and reduced the number of handoffs. Small teams can now develop and deploy code without waiting for other teams to change other parts of the system. There are 3 types of organizational structures to use in our DevOps value stream with Conway's Law in mind: functional, matrix, and market. Functional-oriented organization focuses on reducing expertise and division of labor. Expertise is centralized. This leads to career growth, skill development, and many times tall-ranked organizational structures. Many organizations use this for operations. Next, we have market-oriented organization. Their goal is to responding quickly to customer needs. These are usually composed of multiple cross-functional disciplines. This can sometimes lead to redundancies. Many big, prominent organizations that are adopting DevOps use market-oriented organization. Matrix-oriented organizations attempts to combine functional and market, yet this usually results in complicated organizational structures. For example, individual contributors reporting to 2 managers, and most often, the goals of functional and market are not met.
Traditional IT operation organizations frequently use a functional orientation. This groups teams together based on their specialty. Programmers are with programmers, network engineers are grouped with network engineers, and so on. Organizing in this way seems to make sense, but often leads to long queues and long lead times. Work often gets backed up, and other functional areas must wait for work to reach them. Additionally, when individuals or teams work in a siloed approach, they often cannot see how their work affects the rest of the organization or value stream. When work is done in this manner, there is often multiple value streams that are being serviced. While this sounds good, it isn't. The multiple value streams are left to compete for scarce resources and work cycles. This creates a cascading effect where approvals are required to expedite the work so the team can prioritize and complete it. When every team expedites their work, the net result is that every project ends up moving at the same slow crawl. This then leads teams being unable to keep up with other development teams. This scenario sounds far-fetched, but this happens at lots of organizations where DevOps is not practiced. Market-oriented teams do not focus on specialty or cost. Instead, the focus is on speed, as was mentioned previously. How fast can I get this product out to market or to the customer? While this approach is different from the functional orientation we covered earlier, this can be applied in a functional environment. The key to making this fast and efficient approach work within a functional orientation is based on what everyone in all value streams sees as the end goal. When everyone in the value stream, regardless of their position, sees customer and organizational outcomes as a shared goal. This creates a synergistic space that allows everyone to work cohesively. Additionally, a high trust culture enables all departments to work together effectively. This trust enables teams to work towards shared end goals and creates a more cohesive team. Another approach on team building is to create a team of generalists. When a team is comprised of individuals who can do multiple things, that team is less siloed, and the team members are able to respond to various needs because they have a skill in more than one area. The last item on the slide refers to how money is spent on projects. When we fund products and services instead of projects, we are more focused on the end result, the product or service, and not how we got to that result, the project. This allows our path to that end goal to naturally evolve in the most efficient method to achieve it. We are not bound by checkboxes and processes.
Next, we'll talk about the advantages of loosely coupled architecture and how it compares to tightly coupled architecture. When tightly coupled architecture is used, small changes made within the system can cause large failures, creating an undesired outcome where people must constantly coordinate through complex organizations. Everything within the system is highly reliant on other parts of the system. Furthermore, to test the system's functionality, changes must be assimilated with other changes from hundreds to thousands of developers, who may in turn have dependencies on several interconnected systems. Because of this large-scale integration and dependency process, the testing environment is poorly maintained and rarely done. In short, tightly coupled architecture creates long lead times, low productivity, and poor deployment results. On the other hand, loosely coupled architecture creates a system of small, independent teams who can implement, test, and deploy code quickly and safely without the restraints of complex management. This improves productivity and deployment outcomes. Loosely coupled architecture is also a service-oriented architecture that implements loosely coupled methods with bounded contexts. Services are loosely coupled when they and their databases are kept separate from each other, allowing for independent updates and testing. Bounded contexts refer to services that are user-friendly and organized in such a way that developers can understand, update, and test the services in a straightforward manner without inside knowledge of its peer services. Loosely coupled architecture, being efficient and service-oriented, has the capability to be both flexible and scalable. Another way to use Conway's Law effectively is to keep team sizes small. This is known as the two-pizza rule. The idea is that teams should be small enough to be fed by 2 pizzas. This allows team members to communicate quickly and gain a clear, shared understanding of the work that needs doing. It also limits the system's growth rate and overall development, which may seem counterintuitive. However, by reducing product and service expansion, as well as the rate at which the system can change, teams can preserve their shared understanding of the system and maintain work efficiency. Working in small teams disperses power to create autonomy, allowing teams to work independently on their business objectives. Furthermore, it gives group members leadership opportunities in a safe environment where failure doesn't result in horrible consequences. In conclusion, we discussed how Conway's Law came about through observing the effect team organization has on work. The three organizational archetypes, these being functional-oriented organizations, matrix-oriented organizations, and market-oriented organizations. The problems that occur from using too much functional orientation, such as limited visibility and long lead times. Modeling Conway's Law within team structures, which optimizes for speed. And finally, how Conway's Law can be used the right way to create generalist team members trained to cover multiple areas of work, loosely coupled architectures for improved productivity and deployment outcomes, and small teams through the two-pizza rule.